Dynamic Programming, a Deep Dive. Introduction. Dynamic programming, DP, is a powerful optimization technique used in computer science and mathematics to solve problems by breaking them down into simpler subproblems. It avoids redundant computations by storing the results of expensive function calls and reusing them when needed. This method is particularly useful for solving optimization, combinatorial, and recursive problems. Historical context. The term dynamic programming was coined by Richard Bellman in the 1950s. Contrary to what the name might suggest, it has nothing to do with dynamic or programming in the context of coding. Bellman introduced the term to describe a process of breaking down policies into simpler, overlapping sub-policies. The name was chosen to sound impressive to funding agencies. Core principles. Overlapping subproblems. This is the cornerstone of DP. Instead of solving complex problems from scratch, DP solves overlapping subproblems and caches their solutions for future reference. Optimal substructure. A problem exhibits optimal substructure if an optimal solution to the entire problem contains optimal solutions to its subproblems. Memoization. This is the technique of storing solutions to overlapping subproblems to avoid redundant computations. It can be achieved using arrays, tables, or hash maps. Bottom-up versus top-down approach. The bottom-up approach solves the smallest subproblems first and builds up to the solution of the main problem. In contrast, the top-down approach starts with the main problem and breaks it down into subproblems, often using recursion. Common algorithms and applications. Fibonacci sequence, a classic example where the naive recursive approach can be optimized using DP to achieve linear time complexity. Knapsack problem. Given weights and values of items, determine the maximum value that can be obtained in a knapsack of fixed capacity. Longest common subsequence. Find the length of the longest subsequence common to two sequences. Matrix chain multiplication. Determine the optimal way to multiply a given sequence of matrices to minimize the number of scalar multiplications. Coin change problem. Given different denominations of coins, find the minimum number of coins needed to make a certain amount. Vision of the future. As computational problems grow in complexity, the principles of dynamic programming will continue to find relevance. With the rise of big data and the need for real-time processing. Parallel dynamic programming. With the advent of multi-core processors, parallelizing DP algorithms will become more prevalent to reduce computational time. Integration with machine learning. Dynamic programming can be combined with machine learning techniques, especially in reinforcement learning, where problems often involve making a series of decisions to maximize a reward. Improved storage solutions. As memoization requires storage, future advancements in memory solutions will allow for more efficient and faster DP algorithms. Conclusion. Dynamic programming offers a structured approach to problem solving, turning seemingly intractable problems into manageable ones. Its principles, while established in the mid-20th century, remain as relevant today as they were then, and will undoubtedly continue to shape the landscape of algorithmic problem solving in the future.